Hi students, today I am going to discuss new chapter polynomials. It is very important chapter in your syllabus because the concepts which you are going to learn in class 9 about polynomials will help you to understand the higher level concept of mathematics. Okay, so it's very important to know the basic concept of polynomials which you are going to study in this chapter. Once again, this is very important chapter, so you should go through this chapter thoroughly. So before get deep into the polynomials, let's recall the things which you have learned in class 8 regarding algebraic expression. So the basic terms you have learned, that is first one, constant. What is a constant? A symbol having a fixed numerical value is called a constant. Its value is constant, fixed, it never changes. For example, 5, 7, these all are fixed. That means the value of 5 is 5 at all. In all the situation, it is 5, 7. Similarly, pi. The value of pi which we have learned, that is either we will put as 22 by 7 or 3.14. This value is fixed. So these all are constants. Then what are variables? A variable is a symbol which may be assigned different numerical value is known as variables. For example, x, y, you have learned. X, y, these all things you have learned about algebraic expression. We can put x equal to 3, x equal to 5, x equal to 10. So for different values of x we can assign to x. Therefore, since its value is not fixed, which means its value is varying, because of that we will call x is a variable, y is a variable. These two concepts we need to know. What is a constant and what is a variable. Then what you have learned? Algebraic expression. It is a combination of constants and variables connected by some or all of the operations. Addition, subtraction, multiplication and division is known as algebraic expression. A combination of constants and variables. For example, 3x square. Here constant is the, variable is the plus 5x. This is an algebraic expression because here it is a combination of constant variables. Two constant are there and here one variable is there, which is connected by the operation addition. Not necessarily it should be addition, it can be subtraction, multiplication or division. We can take another example, that is x raised to minus 10 plus 5 root x plus 3. This is also an algebraic expression because variables are there. We can take y instead of x, we can put as y minus 5 root x. So here variable is the, constant is the, again one more variable, that is x, again one more constant. Here it is connected by, suppose we can put here minus. So this is, we are calling as an algebraic expression. Then come to, so we have learned what is a constant, what is a variable and what is an algebraic expression. Then what is a polynomial? Polynomial is a special type of algebraic expression, a special case of algebraic expression. An algebraic expression in which the variables have only non-negative integral power, that is whole number, which means 0, 1, 2, 3, etc. So the power should be a whole number, is called a polynomial. For example, p of x. What do we will call this? P of x. We will represent a polynomial of x. That means in the variable x like this. P, then bracket, then put the x here. Which we will call as p of x is equal to, p of x equal to, we can write as 2x square plus 5x minus 6. This is a polynomial. Because here the power of x is 2, which is a whole number. The power should be a whole number, 0, 1, 2, 3, etc. we can write another polynomial, that is p of y. That means the polynomial in the variable y, which is equal to y square plus 3y cube minus 7y. That means here we are in this chapter we are going to study only polynomial in one variables. Okay, polynomial in one variable. So we can write as p of y, because here the variable is y, so we will write as p of y. Here the variable is x, so we will write as p of x. Clear? But so these two are polynomials. These two are polynomials. Polynomials. But if you consider another example like x cube plus 2 root x plus 6. This is also an algebraic expression. But this is not a polynomial, because if you rearrange this, if you write in another way, that is x cube plus 2 root x, we can write as x raised to 1 by 2 plus 6. So here this algebraic expression consists a power of variable as non-whole number, that is a fraction. So this is not a polynomial. One more example we can take, that is 2 by x square plus 5, which is also not a polynomial, because 2 by x square we can write 2, 1 by x square we can write as x raised to minus 2 plus 5. Here the variable, the power of this variable is negative number. So these two are not polynomials, not a polynomials. So this is the basic thing you have to remember about polynomials. That means all the polynomials are algebraic expression, but not necessary that all the algebraic expression should be a polynomial. Now let's discuss some terms related to polynomial. First, with the terms. Okay, the parts of a polynomial separated by plus or minus operation are called the terms of the polynomial. For example, if you write a polynomial 3x cube plus 5x square minus 3x, here 3x cube together and 5x square and minus 3x are terms of this polynomial. But if you write in this way, 5x into 2x, suppose if a polynomial you have written like 5x into 2x, so in this case 5x and 2x are not two separate terms, it is a single term because it is connected by the symbol multiplication. So the necessary condition is that these two parts should be connected with plus or minus symbol, then we can call that part of the polynomial as a term. Otherwise, which we will not make it two separate terms. For example, this you can simplify it into 5x into 2x, you can write as 10x square. So which will be a single term. Clear? That is a basic concept you need to remember regarding terms. Then what is coefficient? It is the number multiplied to the value. For example, we can write p of x is equal to this is also a polynomial, okay, symbol should be p of x. P of x equal to 5x cube plus 3x square minus 7x. So we are considering this as a polynomial p of x because it is a polynomial in one variable x. So the coefficient of x cube is, what is the number multiplied to the x cube? That is 5 plus 5. So the coefficient of x cube is 5 and coefficient of coefficient of x square is plus 3, because 3 is the number multiplied to x square. Then coefficient of x is minus 7, because the number which multiplied to x is minus 7. The complete number you have to write minus 7. Next we are going to discuss very important term which related to polynomial, that is degree of polynomial. Highest power of variable is called the degree of the polynomial. For example, to understand this, let's take an example. P of x is equal to x raised to 3 plus 5x square minus 10x raised to 5. So here this polynomial consists of 3 terms, and here the power of x is 3, here it is 2, and here it is 5. So the highest power of x is 5, so therefore degree of p of x is equal to 5. Let's take one more example. P of y is equal to, one more example we can take, that is y raised to 4 plus 10y cube minus y square. So in this case, the highest power of, here the power of y is 2, here the power of y is 3, here the power of y is 4. So the highest power of y is 4 among these all three. Therefore, degree of p of y is equal to 4. Next topic is the general form of a polynomial in one variable. It is like p of x is equal to, because we are going to represent in terms of x, an x raised to n plus an minus 1 into x raised to n minus 1 plus etc. a2 x square plus a1x plus a0, where an minus 1 etc. a1 a0 are constant, but an could not be 0, because general form of a polynomial in one variable of degree n, so therefore an should not be 0. How this formula works, because it may look like a little complicated. Don't worry, I will explain with a simple example. For example, I am going to write a polynomial 5x raised to 4 plus 3x cube minus 7x square plus 6x minus 2. This is the polynomial, and here the last term is constant. When we write the polynomial in standard form, we need to write the terms according to the decreasing order of its power. Here it is x power for x raised to 4, x raised to cube, x square, and x raised to 1. X means x raised to 1. Then finally the constant. That constant means there is no value. So this will be a0. And next x. So this will be a1. This x will be a1. Clear? a1 x. Similarly, here x square. So the a2 will be minus 7. a2. This will be a2x square. Then here there will be A3 x cube will be. So this will be A3. Clear? A3. Then here this will be A4. So here you can see these are that constant we have explained here. A2, A1 is 0. And you just here x raised to 4 and here x cube and here it is x square and here it is x raised to 1. So what is the power, what is the value here? An means then the power of x should be n. A raised to A4, that means the fourth term, and x raised to 4. Here A3 then x cube, A2 x square, A1 x raised to 1. So this is the way we are going to represent a polynomial in one variable as a general form. Clear? So whenever you write the polynomial in standard form, write the polynomials with the terms in the descending order of its power. That means from greater to small, and there will be last term that will be constant. But not necessarily always there is all the terms present. For example, sometimes you can write as 5 raised to x, 5x raised to 4 plus 3x square plus 2. So in that case 5 raised to x cube term is not there, no problem. But to represent a polynomial in degree n, the an should not be 0. That means 5 cannot be. Here the degree of this polynomial is 4. Suppose you assign, then the 5 cannot be 0. In between these n terms can be 0, but this cannot. Clear? So these are the basic thing you need to remember about this. And to represent in this way, it is quite difficult. So what we will do is that we will start from here and convert A4 into A, x raised to 4, plus A3 we will convert into B, x cube, plus A2 we will convert into C, x square, plus A1 we will convert into D, x, plus A0 we will write as E. So this is the most convenient way of representing a polynomial in general form. Clear? Ax raised to 4 plus bx cube plus cx square plus dx plus e. Because these all constants are different. A is 5, 3 is b, minus 7 is c, 6 is d, and e is minus 2. Instead of writing A4, A3, A2, A1, etc., it's better to write A, B, C, D, E. Clear? Because in this chapter we are going to study mainly only about up to the degree 3. Okay? We will discuss after this session. Clear? So this is the way of representing general. So this is the general form of a polynomial of degree 4. Now we are going to classify the polynomials based on the concept we have discussed. First classification on the basis of number of terms present in the polynomial, and the second classification on the basis of degree of polynomial. So first, if the number of terms present in a polynomial 1, then we will call that as a monomial. For example, p of x is equal to 2x. This polynomial consists only one term, therefore it is called a monomial. The second one, if the number of terms is 2, then we will call that as a binomial. Bi means, mono means 1, bi means 2. So binomial. For example, p of x is equal to x square plus 5x. That is a binomial because it consists of two terms. Then the third category, that is trinomial. So tri means 3. Okay. So which consists of 3 terms. We can write an example, that is p of x is equal to 7x square plus 5x plus 3. So this polynomial consists of 3 terms, therefore it is called a trinomial. This is the classification on the basis of number of terms present in the polynomial or contains in the polynomial. There are some more classifications are there, but we just need to know up to trinomial, monomial, binomial and trinomial. Okay. Then the second classification is very important, that is on the basis of degree of polynomial. First we can start from 0. In case of degree is 0, we will call that is a constant polynomial. Constant polynomial. Why it is called a constant polynomial? For example, we can write p of x equal to, or anything, okay, p of x or any things we can write, suppose we are writing as 5. So why it is we are writing as 5? 5 is a constant. Why it is called polynomial and why its degree is 0? Because we can simplify into 5 into 1. 5 into 1 we can write as 5 into 1 we can write as x to the power 0. Because if any number, real number with the power 0, it will become 1. So we can write in this form. So the 5 we can write as 5 into x to the power 0. So it is a polynomial with a degree 0. Highest power is 0. Okay, and there is not necessary, there is a general formula. Then there is no general formula because it will be a constant. The second case is that degree is 1. That is called linear polynomial. Linear polynomial. If the degree of polynomial is 1, then that is called linear polynomial. General form will be, for example, if you are writing that ax plus b. For example, here degree is 1, x to the power 1. For example, p of x is equal to 2x plus 3. That is a linear polynomial where a is 2 and b is 3. Because this already I have explained in case of general form how we will write a b, c, d, e, f like that in the decreasing order of power. Now the third category, that is if the degree become 2. If the degree of polynomial is 2, that is called quadratic polynomial. Quadratic polynomial. It is very important polynomial. Okay, quadratic polynomial. So what will be the general form? General form will be p of x equal to a degree is 2, x square plus then b x then plus c, that is the last constant term. Decrease, we have to write in the standard form as in the decreasing order of its power. Then, for example, we can write 2x square plus 3x minus 2. That is a quadratic polynomial. Its degree is 2. And the last one we are going to discuss here is that degree is 2. In case of degree is 3, then we will call that is a cubic polynomial. General term will be p of x is equal to a x cube plus b x square plus c x plus d. We need to write in the decreasing order of its power. For example, we can write 5x cube minus 2x square plus 7 plus 2 plus 7x. But not necessarily there is all the terms, okay. For example, after 2x square you can write it directly 6. The necessary condition is that its highest power should be 3. The other terms can be 0, no problem. The necessary condition is that only the coefficient of the term with the highest power should not be 0. Other term can be 0. Here x is coefficient of x is 0 because of there is no x term. Clear? It's no matter. So this is the classification on the basis of number of terms, and this is the classification on the basis of degrees of the polynomial. This is very important classification. Out of this, quadratic, linear, cubic. This whole concept is very important. So the last topic of this video, that is 0 of a polynomial. What is the meaning of 0 of a polynomial? And it is very important concept. Even in your class 10 syllabus, you need to know basic what is a 0 of a polynomial. A real number k is said to be a 0 of a polynomial p of x if p of k is equal to 0. Let just take an example to understand this definition. What is it? Says that a real number k, a number k is said to be 0 of a polynomial p of x if p of k should be 0. If p of k is 0. For example, we can take, let p of x is equal to x square minus 2x minus 8. Okay, the polynomial here I am taking. Then put x equal to 4. Therefore, p of 4 we are going to find. Instead of x, we assign a value 4. Just I am putting, okay. We assign a value 4. Then it will become p of 4, which is equal to, what is x square? X will become 4. That means 4 square minus 2 into, what is x? X is 4 minus 8. 4 square is 16 minus 2 into 8 is 8 minus 8. 16 minus 8 is equal to 8 minus 8, which is equal to 0. So here p of 4 is equal to 0. Since p of 4 is equal to 0, when we assign the value of x as a 4, then the entire polynomial will become 0. Therefore 4 is a 0 of the given polynomial. P of x. Clear? That is very important. That is what the definition says that. And a real number k is a 0 of the polynomial p of x if p of k equal to 0. Here the 4, the real number 4 is the 0 of the given polynomial p of x because p of 4 is equal to 0. That is a necessary condition. A real number said to be a 0 of the given polynomial. It's very important concept to learn. We will discuss different methods to find the 0 of the polynomial, because in all the cases assigning, putting the value x equal to 1, x equal to 2, it's not easy. So there are some methods to find the zeros of the polynomial that I will discuss in the next part. So, but first of all, you need to know what is the zero of the polynomial. But why in case of linear polynomial? In case of linear polynomial, that's why I have written here one more statement, that is find the zero of a polynomial means solving the equation p of x equal to 0. That means that is another case. Okay, we will, when we solve the polynomial to find the 0, we will put equal to 0, then what value of x will be better. That is the thing. So final answer should be, the RHS should be 0, then only that number we will call as 0 of the polynomial. So this is the basic thing you need to remember. But in case of linear polynomial, 0 of linear polynomial is very easy. Polynomial, very easy to find. For example, p of x is equal to 3x plus 5. Okay, this is the polynomial given. So to find 0 of the polynomial, we are solving the equation p of x equal to 0. So let p of x is equal to 0. That implies 3x plus 5 is equal to 0. Then that implies 3x is equal to minus 5, x equal to minus 5 divided by 3. So here x equal to minus 5 by 3 is a 0 of the polynomial. Therefore, minus 5 by 3 is a 0. 0 of p of x. And when you put p of x equal to 0 in case of linear polynomial, that will become linear equation in one variable. That's why we are calling this as a linear polynomial. Clear? Let's check it whether it is a 0 of the polynomial. Just to check it here, put those values here. What we will get here? 3 into minus 5 by 3 plus 5. This 3 cancel, which is equal to minus 5 plus 5, which you will get a 0. So for the value of x, equal to minus 5 by 3, we will get the entire polynomial becomes 0. That's why this is called the 0 of the polynomial. But in case of linear polynomial, no need to solve like this. You can directly put equal to 0. You can directly find the 0 of the polynomial. But in case of quadratic polynomial, it is very quite. If you are putting equal to 0, we will get another equation. It is not linear equation, so it is little difficult to solve the equation. So we will discuss the method to find the 0 of the quadratic polynomial by factorization and the factor theorem. Okay, that I will discuss in the next video. These are the these topics are very important, and in the next video I will continue the same chapter with the another topic. Thank you all.